Hi everybody, welcome to Unit 2, Video 4. If you do not have your Unit 2 notes out, please go ahead and get them now. All right, so it says, I can graph and identify the difference between a linear equation and an absolute value equation. So let's see what we have here, y equals x. So this is a linear equation. It's in slope-intercept form, y equals mx plus b, since the b here is 0 and the slope is 1. So we would start at 0 here. And we go up 1 over 1, up 1 over 1. And we continue. You can also go the reverse, down 1 to the left 1, down 1 to the left 1. And we'd connect our dots. So this linear equation, since it starts at the origin, 0, 0, and has a slope of 1, we call it a parent graph or a parent function. So this is the parent graph of a linear equation. I'm going to put linear. All right, now if you look at this one, this is an absolute value. And since it's y equals the absolute value of x, you could make a t-chart if you wanted to, or we can just plug in values and for x and solve for y. So if I plug in 0 for x, the absolute value of 0 would give me 0. So the first coordinate would be 0, 0. Now if I plug in 1 for x, the absolute value of 1 is 1. So it means y would be 1. If I plugged in 2, the absolute value of 2 would be 2, so I'd get 2, 2. I could also try some negative numbers. If I plug in negative 1 for x, the absolute value would be a positive 1, so I'd get negative 1, positive 1 is my next coordinate. If I plugged in negative 2, the absolute value of negative 2, y would be a positive 2. So you can kind of see the pattern that's going on here. So I'm just going to go ahead and continue that pattern. And I'm going to graph these coordinate pairs, and you should start to notice what shape this absolute value graph is taking. And so if you haven't already noticed, it's taking on this V shape. And so right here. And so since this one, y is equal to the absolute value of x, this is what we call, again, this is the parent graph. And this is an absolute value equation. So I'm going to put here absolute value. Oops, value. All right, and it's going to make this V shape, where the linear will make this straight line. This one's going to make a V shape. Okay, so now that we know the difference between linear and absolute value, let's go ahead and do some more with absolute value functions. So based on the equation of the absolute value function, I can recognize and graph an absolute value function that has been transformed or shifted. So let's take a look at this one again. So f of x, remember f of x is the same thing as saying, like, if you wanted to think of it as y equals the absolute value of x. So we already know what that's going to look like because we just graphed it. So I'm going to quickly sketch it here. So here's some coordinates. And again, if you forgot how to find the coordinates, you could always just plug in a number for x and you solve for y. All right, so here we go. So this is my parent function, and sorry that my line is a little, it should be straight. So do the best that you can. Hopefully you're using a ruler. So everything is going to move in relation to this parent function. So right now here, we have y equals the absolute value of x minus 2. So we have to figure out what this minus 2 is going to do to our function. Well, let's start with 0, 0. Or sorry, let's start with x equals 0. So if I plug in x equals 0, and I solve for y, I'd get 0, negative 2, which would be right here. And if I plug in 1 for x, and I say the absolute value of 1 is 1, minus 2 is going to leave me with y equals negative 1. So that means 1, negative 1. If I plug in 2 for x, the absolute value of 2 is 2. So 2 minus 2 would be 0. So now you can kind of see the shape it's taking again. So I'm going to go to the left-hand side. So I'm going to go here to the negative side. So if I plug in negative 1 for x, the absolute value of negative 1 is 1. So 1 minus 2 is going to leave me with a negative 1. And if I plug in a negative 2 here, the absolute value of negative 2 is 2. So 2 minus 2 is 0. So you can probably see how this is going to continue. And again, if you wanted to get all these coordinates that I'm plotting, you could keep plugging in values for x to solve for y. So I'm going to connect my dots here, get my absolute value function. All right, so if you notice, if this is the parent graph, the one that starts at the origin, everything rotates or moves from the parent function, you'll now notice the vertex. Remember, your vertex is your starting point down here. It went down 2 from the origin. So since it went down 2 or moved along the y-axis, we call this a vertical shift. So it's a vertical shift. And you want to say down 2 units. So it's a vertical shift down 2 units. All right, so let's go ahead and go to the next page. So again, we're trying to see how does everything move about from the parent function. So the last time the equation had a number on the outside and the x was in the absolute value by itself. But now if you look at this function here, you have a x plus 1 on the inside of the absolute value. So let's see how this is going to make it shift from the parent function. So let's plug in 0. So if I plug in 0 for x, I'd get 0 plus 1. And then I would say, okay, 0 plus 1 is 1. The absolute value of 1 is 1. So 0, 1 would be my coordinate here. All right, well, let's see now what happens if I plug in 1. 1 plus 1 is 2. The absolute value of 2 is 2. So that means I'm going to get this point right here. If I plug in 2, 2 plus 1 is 3. So the absolute value of 3 is 3. Okay, so I'm going to go now to the left here, negative 1. Negative 1 plus 1 is 0. So the absolute value of 0 is 0. Oops. Now I'm going to try if I plug in negative 2. So negative 2 plus 1 is a negative 1. So the absolute value is going to give me 1. All right, and so we notice something's happening. It's kind of turning back up. So if I go over here to negative 3 plus 1 is going to give me a negative 2. The absolute value of negative 2 is 2. So, and I'm going to try one more point, negative 4. So negative 4 plus 1 is a negative 3. The absolute value of negative 3 is 3. All right, and so now that means that this point over here, we have negative 1, 0. That is our vertex point. So that was our starting point because that's where our absolute value went back up. It went up and to the left. So if I connect these right here, here's my absolute value. So you want to say, okay, well, how did it shift from the parent function? Remember, the parent function starts at the origin. It starts at 0, 0. And if you notice, now this one, the vertex starts at negative 1, 0. So that means it shifted to the left 1 unit. So if it goes left or right, it's called a horizontal shift. So this is a horizontal shift. And since it went to the left, you'd say left 1 unit. Okay, so now that means that if something happens on the inside, it's going to shift left to right. Remember, when the number was on the outside of the absolute value, it went up or down. So, and if you also notice here, this was a positive 1, but it went to the negative side of the number line. So it's shifting to the opposite of what you have, the opposite side. So if this is positive, it goes to the negative side. So if it was negative, it'd go to the positive side. So let's take a look at what we have here. We have two things happening. You have a number on the inside and a number on the outside. All right, so I want you to pick some numbers for x, solve, and for y, and then plot your coordinates. And I want you to kind of see where do you think, but before you do that, try to think, where is the vertex going to be? How is it going to shift from the parent graph, from 0, 0? So pause the video and see what you get. Okay, so how did you do? So from the parent function, from 0, 0, remember we said if the number was on the inside, it's going to go left to right. Since this was negative 3, it went opposite of the number line. So we went to the right 3 units. And then plus 1, so it meant it was going to go up or down. Since it's plus, it went positive, so we went up 1 unit. So the vertex went is now at 3, 1. So from the parent function, we went to the right and then up. So to the right, we say a horizontal shift. So a horizontal shift. And we went to the right 3 units. Then we went up. So we went a vertical shift. And we went up 1 unit. All right, so if you notice, it went diagonally from 0, 0. It made like a diagonal line from the origin. Okay, so let's go ahead and complete each sentence. The graph of the translation f of x equals the absolute value of x. All right, so g of x equals x minus 2 shifts the graph of f of x equals absolute value of x. So how would it shift it? Well, since it's on the inside, it's going to go left to right. Since it's negative, you go opposite of the number line, so it's to the right 2 units. All right, g of x equals the absolute value of x plus 1 shifts the graph of f of x, absolute value of x, while it's on the outside. So remember, the outside is going to shift it up or down or vertical, and since it's positive, it's going to shift it up. Oops, up. All right, I want you to try to do these next 3. So I want you to pause the video and see what you get. So fill in the blanks, please. Okay, so how did you do? So number 13, down 3 units. Number 14, it went to the left 3 units. Number 15, it did diagonal. It did 2 different things. It went to the right 1 unit, and it went down 5 units. Okay, so that is talking about shifting from your parent function, the one that started at 0, 0, or y equals the absolute value of x. All right, so let's go ahead and go to the next page. So the next type of graphs that we're talking about here are absolute value graphs, but except this time we're talking about inequalities. So it says, I can recognize, graph, and identify and name 3 solutions of an absolute value inequality. Okay, so first what we want to do is we want to still graph the parent function. So you could, again, you can plug in your numbers for x, solve your values for y, but since you already know the parent function, we know it's going to start at the origin, and then I knew it went up. When I plugged in 1, I got 1. When I plugged in 2, I got 2. So it's going to go up this way. All right, but the difference is, and what you have to be careful about, is now that it is an inequality, which means it's not necessarily always going to be a solid line. Like if you think about when you did your open circles or closed circles on a regular linear equation. And we also know what an inequality, that's when you had to, on your graphs, you either shade it above the line or below the line. So this one, since it's y is greater than the absolute value of x, it's greater than, it's not equal to, so it means something on the line can't be a solution. So it means it's going to be a dotted line or a dashed line. So I'm going to draw my dashed line here. Okay, but we're saying y is greater than the absolute value of x. And when something was greater than, you have to shade above or above the line. But in this case, it's above the absolute value. So that means anything above this in the shaded region is a solution. And since it says name 3 solutions, we have to identify those solutions and then verify that they work. So I'm going to change my colors here. So I'm going to try, I'll try 0, 4. So that would be right here in this shaded region. So if I say, okay, 0, 4, let's test that out and see if it works. So I'm going to plug in 4 for y is greater than the absolute value of 0. So 4 is greater than 0, so that works. That is a solution. And remember, since it's greater than, it's not equal to, it's dashed, so you can't pick a number on the absolute value itself. So I'm going to try 4, 7. So let's try 4, 7 over here. So 4, 7. So if I plug it in, I'm going to get 7 is greater than the absolute value of 4. So 7 is greater than 4, and that works. All right, so try 3 of them. So I'm going to try one more. So let's try -2, 6. So over here, I have -2, 6. So I'm going to plug in 6 is greater than the absolute value of -2. So 6 is greater than 2, and check, it's a solution. So I know I shaded it correctly because everything in that shaded reason worked. All right, let's go ahead and take a look at this one here. We have y is less than or equal to the absolute value of x. So again, I already know what my parent function start at the origin, but again, you could plug in numbers for x and y and find the coordinate pairs. But this time, this inequality is different because it's saying it's less than or equal to. And remember, when it was greater than or equal to or less than or equal to, you have a solid line, which means something on the line itself can be a solution to your inequality. Oops. Okay, so this one, y is less than or equal to the absolute value of x. Remember, less than, you shade below. So I'm going to shade everything below the line or below my absolute value here. So I'm shading it here. And then it says I need to check 3 of them. In this one, you're allowed to, when it's equal to, it's a solution can be on the line itself. So I'm going to try right here. I'm going to try this coordinate 2, 2. So I'm going to plug in 2, 2. So 2 is less than or equal to the absolute value of 2. 2 is less than or equal to 2, which is a true statement, so it works. All right, I'm going to try 4, -1. So I'll pick a coordinate here. So I'll try 4, -1. So I'm going to plug it in. So I get -1 is less than or equal to the absolute value of 4. -1 is less than or equal to 4. That is a true statement, so it worked. And the last one I'm going to try -6, 0. So let's try -6, 0. So 0 is less than or equal to the absolute value of -6. 0 is less than or equal to, less than or equal to 6, which is true. So it worked. Okay, let's take a look at our next 2 problems. All right, so now we notice that they have, this one has a number on the inside. So we have to go back to what we did a little bit earlier. If it's on the inside, is it going to shift horizontally or is it going to vertically? Meaning, is it going to go left to right or is it going to shift it up and down? Since it's on the inside, it means that it's going to shift it horizontally, left or right. And since this is a positive 2, it means it's going to do the opposite. So it's going to go over -2. So it's going to go here. So it's going to go over to the left 2 units at -2, I should say. So it's shifted from the origin 2 units to the left. And again, you could plug in numbers for x. You can plug in -1, solve for y, and write your coordinate pairs. But I'm going to go ahead and plot. And this one here, since it's saying y is less than, it doesn't say equal to, I know that I have to draw a dashed line. So I'm going to draw a dashed line. And remember, from the parent function now, your vertex shifted to the left 2 units. Okay, so less than means I'm going to shade below. So I'm going to shade everything below here. And then it asks me to check. So I'm going to go ahead and pick some points in my shaded area. So I'm going to try 2, 0. So let's try over here. All right, so if I go ahead and plug in, so 0 is less than the absolute value of 2 plus 2. Then I get 0 is less than the absolute value of 4. And so 0 is less than 4. So that is a true statement, so it worked. All right, let's try -4. Oops, -4, -1. Sorry, this is -4. So -4, -1 would be down here. All right, so I'm going to get -1 is less than the absolute value of -4 plus 2. So -1 is less than the absolute value of -2. So then I get -1 is less than 2. So that worked. That is a true statement. Okay, and then let's try one more. So I'll try 0, -2. So down here. So 0, -2. All right, so I get -2 is less than the absolute value of 0 plus 2. So -2 is less than 2. So -2, or sorry, the absolute value of 2, which is less than, so -2 is less than 2. Okay, so I want you to try this one. And again, remember, if the -4 is on the outside of the absolute value, where is it going to shift? And also, this is greater than or equal to. So what kind of lines are they going to be? So pause the video and see if you can do it, and also try to check your solutions. Okay, so let's see how you did. So since it was on the outside, -4, it means it got down 4 units. It's a vertical shift. So from the parent function at the origin 0, 0, the vertex now shifted down 4 units. Also, it was greater than or equal to, which meant it was a solid line. So it means a solution could be on the line itself. And since it was greater than, we shaded above. So everything above. All right, so then here are my 3 coordinates that I verified that worked. And so I did choose one that was on the line because it's solid. And so when I did -6, 2, and I plugged it in and I simplified, I got 2 is greater than or equal to 2, which worked. So it was a solution. And then here's my other 2 points that I checked to see if they were solutions to my absolute value inequality. All right, well, thank you for watching the video.